Alright, the next special segment that we're going to look at is called a median. And a median is a segment with endpoints being a vertex of a triangle, so an angle of a triangle, and the midpoint of the opposite side. Alright, so if I look at this picture right down here, D is considered my midpoint of AB, and my median is this segment CD because it goes to an opposite vertex C and to a midpoint D. When we find the three medians of a triangle, we get the point of concurrency called a centroid. A centroid is always going to be inside the triangle. One thing that you can use to help you remember a centroid is kind of the center of the triangle, or what we consider the balancing point. Alright, so we're going to create this centroid here first. I've got a triangle here. Alright, I'm going to find the midpoint of each side first. Okay, I'm going to find the midpoint of each side. So if I find it first, there's D. D is the midpoint of BC up here. My pointer's on it. Okay, I'll find the midpoint of the other sides. There's E and there's F. Okay, those are all the midpoints of the sides of the triangle. Now I'm going to form my segments. And if I put my first one in here, okay, this segment right here, BE, notice how it goes from the midpoint to the opposite vertex. Okay, so I'm going to do that with all three of them here. Alright, this point of concurrency right here in the middle, where my pointer's at, I'm going to label it as G. Alright, that is my centroid. Now the interesting thing about a centroid is this theorem right down here. Alright, extend my page so you can kind of see it here. If I just take one of these medians here, let's say I focus on, let's go with AK here. I'm going to highlight it for us so you can see that. Alright, if they give me the length of AK, I'm going to know that this segment right here, this AP, kind of put a couple tick marks on it so you can see it, that AP is 2/3 of the whole thing. So if I give you the segment AK being something, alright, I don't know exactly what the length of AK could be. I know that AP is 2/3 of this segment. Okay, now if we think of it on the flip side, if I wanted to find this segment right there, PK, I even know that that is a third, or 1/3 of AK. Okay? And that is true with all of them. If I go back to my picture over here, alright, I think I'm going to focus on that median FC, for example. I'm going to put those lengths up there. I know that my length FC is 9 units long. Okay, I know it's 9 units long. I know then my bigger segment, GC, is going to be 2/3 of 9. So I take 2/3 times 9, I would get 6. Likewise, if I would do this one over here, FG, if I wanted to find that one, I would take 1/3 of 9, or 9 divided by 3, which is 3. The other interesting part about this is if I would focus on the two smaller segments now, GC, this one right here, and GF right here. Okay, notice how GC is double FG. So in other words, I could take my segment 3 here and I could multiply it by 2 to get me this. Likewise, if I wanted to go the other way, I could divide by 2 or take it times 1/2 in order to find those segments. Okay, so let's do those in terms of some examples here. In triangle ABC, G is the centroid and BE equals 9. Find BG and GE. Okay, so I'm first going to find BE. I notice BE is right here. I know that that entire segment is 9 units. Okay, and it wants me to find BG and GE. Kind of like the last example that we did. If I know that my whole segment is 9 units, to find BG, notice how this segment is just a little bit longer than this one right here, QE. BQ is 2/3 of 9. So to find BQ, we're going to take 2/3 times 9, which If you can do that in your head, that's good. If you can't use your calculator, that is going to be 6. Alright, next we would want to find QE. Well, finding QE, that's the smaller of the two portions of my median. That is a third of 9. So we take 1/3 times 9, and we would get 3. Alright, I'll do these down here at the bottom with you as well. They're using the same picture. I'll slide my picture down so we can see it better. Alright, this time it says FC is 15. So I'm going to find FC. Here it is right there. That is 15. And it wants me to find FQ, which is right here. And it wants me to find QC, which is right there. Alright? Well, let's focus on the bigger first. Let's start with 1B, finding QC. Okay, that's the bigger portion. That is 2/3 of the whole thing. Alright, so if I take 2/3 times my whole segment, which is 15. 15 divided by 3 is 5, times 2 is going to give me 10. Likewise, if I find FQ, FQ is the smaller portion of the median, that is 1/3 of the whole thing. So I take 1/3 times 15, which is really just 15 divided by 3, which would get you 5. Which, if I would add both of those parts back up, 10 plus 5 should get me 15. That's one way that you can easily check this. Alright, we're going to go on to another example here as well. Example 2, use the centroid theorem in triangle JKL, PT equals 2, find KP. Alright, use a little bit of number sense here to help you with this. Here is PT right here, and they want me to find this segment right there. Alright, well if I know that this is 2, notice how that's the smaller portion. All I need to do to that number is take it times 2, because KP is double that. Alright, so 2 times 2 is going to get you 4. That's easy. That's just how easy this is. Alright, likewise, if I go down here to these, let's start with 2A wants me to find PL, which is right there. Alright, well I need to know something about another portion of that segment, and that is going to come off of this right here. RP is 3.5. RP is right here. Notice how that's the smaller section. I'm looking for the bigger section, so all I would have to do to that number is double it or multiply by 2. So 3.5 times 2 is going to give me a length of 7. Alright, let's also look at PS here. Erase those so I can see this better. PS is right here. I want the smaller portion this time. Alright, and that's going to come off of JP, which is equal to 9. That's right here, that segment. Okay, I know that that segment is 9. If I want to find the smaller portion, all I would have to do is take 9 divided by 2 this time, or 9 times 1/2, and that would give me the segment 4.5.